So good morning, good afternoon, good evening, judging by the chat responses. It looks like we have a very diverse crowd from all parts of the world, which is great. So thank you for joining. The title of my talk today is Moving the Needle Toward Organizational Success, and I'll include just a general framework for decision making. I think it applies in multiple areas, not only in sports, but also in business. And then I also just want to make note, if you can, please go to this link, this Slido link, which there will be a question here. We have a dice game that we're going to roll through. So please make sure, make use of that as we get going here. So just a few disclaimers as I get started. The field of sports analytics is an extremely broad, diverse field. The 15 to 20 minutes today that I'm going to talk is going to be a heavy bias toward American football. Trying to cover the entire field of sports analytics in 15 to 20 minutes just isn't possible. But ideally, the takeaway, that I hope for you is that you're able to take something away from this that's it's a pragmatic solution to solving difficult problems, whether that's in sports, business, or just general life when you're forced to make a difficult decision. Then one general framework that you can apply to making that decision, and then obviously using data to help inform that. So I had to include this in here at the beginning. So for those of you that are familiar with the movie, this is from Moneyball. It's Jonah Hill's character. And if I had $1 for every time someone had asked me, so you're like the guy in Moneyball, I'd probably be retired somewhere on a beach by now. But in terms of the reason I wanted to include this is that there's a couple different, I think, misnomers about Moneyball, what it is, what it isn't. So I'm going to throw my 2 cents in here. In my mind, if you approach Moneyball as a general philosophy to using data to help inform decision making, I think that's a really good definition. If you limit Moneyball to just player acquisition, player selection, I think that's a more narrow focus. And I'm going to get to a couple different concepts here throughout my talk, but just wanted to make note of that because I think quite often sports analytics, the first term that everyone throws out is Moneyball. And while player acquisition is and how you acquire players using data is certainly a piece of sports analytics, it's not everything. So again, hopefully we'll get to that here in a little bit, and I'll be able to demonstrate that in more detail. Okay, so if everyone can, please take a look at that Slido. We're gonna roll some dice here. So there's this is a Shiny application, and this is publicly available. You can go out to this site, and what we're going to do is I'm going to go over the rules here just briefly. And once I cover the rules, what I'd ask you to do is please go to that Slido site. Again, this is part of the challenge of doing something on Zoom compared to doing it in person. But if you can, go to the Slido site and please vote whether or not, yes, you'd want to play this game. No, you don't want to play this game. And that last response, as I'm looking at this other slide or this other screen here, is I'm not sure. I didn't think I was going to have to calculate anything here today. So I'm going to go ahead and enter the names, and then so I'm going to be player 1 for this game. And Rachel didn't know it, but she's going to be player 2. All right, so here's the concept. We're going to simulate a dice roll of two dice. And then we're going to take the sum of those 2 dice. When you take the sum of those, nothing earth shattering here, it's going to yield a sum between 2 and 12. But there's going to be associated payouts with the results of those dice rolls. So the way this game is currently constructed, if you see here, is that my winning numbers are 8 or less. So anytime that the sum of the 2 dice is 8 or less, Rachel's going to owe me $45. Okay. Now, on the flip side of it, the second component is that if the sum of the dice is 9 or more, I'm going to have to pay Rachel $108. So you're looking at it now, there's a pretty sizable difference in the payouts, but there's also a difference in terms of the winning numbers. So just based on that, so if you can just take 20 seconds or so, and I'll get rolling on this. Please go to the Slido and vote. Yes, I'd play this. No, I wouldn't play this, or I don't want to calculate anything right now. So I'm going to take the default answer as not sure, and I'll monitor the results here.
Mitch, I think you might just need to tell me when to end the poll, and then you'll see
the
results.
Okay.
Let's see. So far, we have 50 people that have done it. So just let me know when you want me to.
Yep. I'll give everybody a few more seconds here.
And then for anyone who hasn't seen the Slido yet, the short link to it is rstd.io/sport. And I'll copy that again in the chat.
Yeah, Rachel, why don't we go ahead and stop it there? I think we got a pretty good sample there. So looks like most people are saying yes, they would play this. A few folks are saying no, and then there's a handful of folks also that are saying they're not sure. So that's all fair. So let's go ahead and roll this, and I'll demonstrate what's going on here. So as you can see, we just selected one roll to simulate, and what we're going to focus on is the results here, this rolls detail section. So dice 1 was a 2, dice 2 is a 6, the sum of that's 8, so I win $45. And this is randomly generated. So I'm just going to continue to click roll them, and you'll see that there's some variance here. Those numbers are updating. There you can see that Rachel won that roll with a sum of 9. So as I'm doing this, we can do this at one roll at a time. Well, I don't want to play one roll at a time. I want to do this multiple times. So let's bump this up to 100 and roll this. Okay, now obviously the payouts are getting a little bit bigger. I just won a little over 3,000, but I had to pay Rachel 2,700. So net difference is 675. So now as I'm starting to increase the number of rolls to simulate, what I'd ask you to focus on is this section in here, the summary results. Again, there's variance. I'm winning a little bit. I'm winning a lot. Okay, and again, this is publicly available. You can go to the site and experiment with it, but I'm just going to go ahead and bump this up to 10,000 and let this run. Okay, so when I ran this 10,000 times, so we just simulated 10,000 dice rolls, and to show that there's 10,000 in here, this is a summary. This is the tail of that data set that was just generated. So you can see that Rachel actually won the last roll. And again, you can export this data, copy it. You can look at it in more detail on your own. But the more times we play this, the more I'm winning. Hopefully that's the takeaway here. Another takeaway is that there's certainly variance that's associated. So let's go ahead and deconstruct what's going on here. And for those of you that said yes, hopefully you said you wanted to play as player 1 and not as player 2. And for those of you that said no, hopefully you were looking at it from player 2 and not player 1. So the general framework for this game and just in general that I like to apply is that expected value is equal to the sum of the probabilities and the payouts. And some of you that are in academia might be looking at that saying, hey, wait a second, there's this great summation notation that highlights exactly what I just said. And I would agree. I put this on here in this context for two reasons. One is that as an undergraduate math major, I reached a certain point, I think, through my undergraduate classes where I was writing proofs, and I said, you know what, if I have to put some sort of formula, I'm going to try to deconstruct it into simpler terms. So that's one reason why this is on here. The second reason I put this on here in this context is just the sum of the probabilities and the payouts, is that when you're presenting sometimes to non-technical audiences, whether that's a coach, an executive, someone in your business, I think sometimes the notation can be a little off-putting. So being able to deconstruct that into simpler terms, I think is one technique or one strategy I would recommend for your organizations. Okay, so why this works. By the way, has everyone seen this red? Okay, there it's gone. I think somebody was taking a note possibly. So what we're looking at is this is the outcome of possibilities essentially. So dice 1 is on the X, there's on the horizontal axis. Dice 2 is on the Y, and these are the way that the sum could possibly turn up, right? So there's 36 different squares here, and you see 7 across the diagonal and so forth. So when we add the players, you can see the advantage. The advantage is certainly to player 1. Player 1 has more numbers, so there's 26 out of the 36 squares that's where the advantage is to player 1. But recall that player 2 has a much higher payout. So player 2 has fewer squares, winning squares, but there's a much higher payout that's associated with player 2. So again, going back to that calculation of why this works, why expected value. So when you go through the math, again, it's the sum of the probabilities multiplied by the payouts or the outcomes. So again, this calculation, this entire calculation is from the perspective of player one. So we're looking at this from player one's perspective. Okay, so for player one, again, 26 out of 36 with a payout of $45. And there's a key point here that I wanted to highlight is that for player, again, looking at this from player one's perspective, player two wins 10 out of the 36 times, and there's a negative payout associated for player one when player two wins. That's where that negative comes in. Okay, then when you do the math, you get to this bottom line, and this is the key takeaway: is the way the game was constructed. It was not rigged from a variation standpoint. Those were random dice rolls. It's just using sample within R. But the way that the game was constructed was rigged for player one. Player one, every time that those dice were rolled, player one had a $2.50 advantage. So from player one's perspective, if somebody offered me that game and we could play that all day, I would play that game happily all day, every day, because I know that the more times I roll those dice, the more times I'm going to win. Okay, so there's a couple of things there. One is that there's a small advantage, and that's going to equate to a significant gain in the long run. Another piece is that there's variation. You got to be able to withstand the losses, and I'm going to get to that here in a few moments. But there is certainly variation, and it happens. The way that I had it constructed, I was winning overall, but Rachel certainly won her share as well. So I'm 7 slides in, and you might be wondering, this guy hasn't said anything about sports yet. When's that going to happen? So that's where so now we've reached that point. So I wanted to set that framework because it's an extremely important framework that applies to multiple decision-making processes within a front office, within a coaching staff, within a sports performance staff, within a contract and labor perspective. But ultimately, it comes down to win probability. So if you're familiar with win probability, multiple media sites have different variations of this. Both of these are screenshots from the Super Bowl last year. The one on the left is from ESPN, and the one on the right is from NumberFire. I also want to mention some of the work that's done in the public sphere with, I believe, Lee Sharp on Twitter has a version of this as well, and those are animated. So these appear in different formats. But the key takeaway from this is that what these lines represent is that at every point in the game, it represents the likelihood that the team that's on offense or the team that possesses the ball is going to win. So there's variation. You see these things move a little bit. And then if you recall the Super Bowl from last year, Tampa Bay ended up dominating the game, which is why the last 2 quarters or quarter and a half that their win probability was close to 100 the entire time. And again, these graphs appear in different formats. Sometimes it's a single line, sometimes it's multiple lines, sometimes it's flagged by key events and where those occurred in the game. Sometimes there's a time component. So again, just to clarify this is value on the Y and it's time on the X. Okay, so why win probability? Why is this such an important piece? Because ultimately win probability is what you're trying to maximize, but you're trying to add value with win probability. So I'm going to talk a little bit. I have a couple links on the next slide. There's no shortage of information about 4th down decision making. If you're familiar with the football analytics, American football analytics space, there's no shortage of information available on 4th down. But I wanted to take a slightly different approach here, and I wanted to talk a little bit about challenges. So again, if you're not familiar with the game, the short version of the summary of what you're seeing in this GIF is the head coach from an NFL team carries around a red flag in their back pocket. And essentially, they have 2 opportunities a game to be able to challenge a ruling on the field. And I'll go ahead and open this link. And once we post these slides, you'll be able to access this on your own. So there's a site that the NFL maintains, and you can actually test yourself and whether or not you would challenge that ruling. So again, you have 2 opportunities to do that throughout the course of a game. And the way that I approached it when I was working for teams was from an expected value standpoint. There's going to be a net change in win probability based on the decision, but there's also a probability associated with the likelihood of a reversal. So again, using our context for expected value, it's the sum of the probabilities and the payouts. And this is kind of the summary takeaway here is that when there's essentially 2 different outcomes that can happen when you challenge. It can either be reversed or it stays the same, and that's it. So if it's reversed, ideally, if you're challenging it, it's going to be a positive change in win probability of a reversal. So that's the first part of this equation down here on the bottom of the slide. It's that reversal rate, what that reversal rate is, multiplied by the positive change in win probability of a reversal. The second part of it, from an expected value standpoint, is going to be 1 minus the reversal rate multiplied by that negative change in win probability. So there is a catch. There is a penalty associated with challenging unsuccessfully. If you challenge a play, you lose a timeout. So at various points of the game, that timeout takes on very different meaning. And that was one of the first questions that I was asked when I first started working for teams is, what's the value of a timeout? And I thought it was a really interesting question because there's a lot of different ways to answer that question. And based upon where you are in the game, and this can be a conversation for another day, but where you are in the game certainly makes a difference. Now, ideally, the way that I tried to approach this was I really tried to focus on this first part of this, is that, again, in a perfect world, what you just saw was clearly wrong on the field. And the advice or the recommendation down to the coaches on the field is challenge it. There's a high likelihood that it's going to be reversed. So ideally, this is close to 1. And ideally, this positive change in win probability of a reversal is high. So where does that come into play? That comes into play when high leverage situations. And if you going back to these slides previously, win probability at the end of a game can fluctuate significantly based upon the plays and what's happening. So when you're in high leverage situations, ideally this is close to 1, and this is a huge swing in win probability. It doesn't always turn out that way, but when you're trying to maximize decisions and trying to make positive expected value bets, essentially, that's kind of the perfect context there. And again, we have time for Q&A, so I'm more than happy to answer more questions there about the challenge process. Some additional applications. Again, it wouldn't be a presentation on football analytics without mentioning some of the fourth down work that's publicly available. There's some really good work historically from Brian Burke. Ben Baldwin recently did an updated version of this from The Athletic. And then the league office also posted a video after the playoffs talking about the importance of fourth down decisions. And as you go through these links, I would encourage you to go through them. Again, this is an overview of sports analytics. I would encourage you to go through those and look at how they're using similar frameworks for decision making. And it's essentially expected value based on the outcomes and then the results associated with those outcomes. Now, there certainly are other applications. To my point earlier about Moneyball not being the end all be all, there are other applications. And I'll run through these relatively quickly. Again, a lot of these could be their own presentations. But from the personnel standpoint, personnel staffs are responsible, for player acquisition. So in an NFL front office, that can be either on the college side or on the pro side. With professional baseball teams, it's often referred to as amateur scouting, this side of the personnel department. Player performance is another extremely important piece, and with all the tracking technology that's available, not only for practice, but also for games. And this is also commonly referred to as sports science or load management. Load management is certainly a term in the NBA that you've heard publicly. And then the last major area is cap and labor, and that's how you value contracts. There's a lot of different ways to value a contract. And again, these are all applications where that expected value framework can help your organization make positive gains in the long run. And as I wrap up here, I just want to mention a couple lessons learned from this exercise. Really, this is a summary not only from the exercise, the Shiny application, but just in general. I'm trying to, when I was putting this presentation together, I wanted to try to anticipate what some of the questions might be. And hopefully this captures some of the potential questions. Again, I'm happy to answer more of these as we get to the Q&A section. But the first one is consider framing your decisions as bets. And if you're not framing your decisions as bets and you're just simply looking at it at a deterministic level, I would highly encourage you to look at your decision-making from a probabilistic mindset. Even something that may be perceived as 100%, whether it's a reversal rate, it's a player selection, it's a coaching decision, it's a contract decision, I would argue that things that are 100%, there is other things can happen, and they do happen. So that's why I would highly encourage a probabilistic mindset. Another key piece here is that small advantages can equate to significant gains in the long run. And hopefully that was illustrated or highlighted in the short demonstration with the dice rolling. Small advantages, when you do that over over longer time horizons, and you do that at length, those equate to significant gains. I've already touched on this luck and variance piece. It's real. It happens. Things happen in sports. players slip, somebody falls down, everything else could go right on the play, but somebody slips, it's bad luck. It happens. But on the flip side, the ball can also bounce your way. And then the last piece is extremely important. It's valuing the process and placing a greater emphasis on the process rather than the outcomes. It's a really difficult thing to do, especially when you're talking about a 16 and now 17 game season for NFL teams. It's an extremely difficult thing to do because there is such a limited number of games. But if you value the process and understand that luck is going to happen, but you place an emphasis on the process, and you can live with when you're making best decisions that are maximizing expected value, then in my mind, that's a really good framework for operating. I'm sure there's a number of people on this call that are attending that maybe are unfamiliar with sports analytics, want to do something. So here are just some general recommendations on how to get started. One is, first and foremost, is go do something. That's a question that whenever I was asked by students, my first questions would be, what have you done lately? If you're not familiar with the Big Data Bowl, I would highly encourage you to go look at this information. Credit to Mike Lopez at the NFL League Office for starting this and continuing to push this forward. The volume of data has changed significantly in recent years for the NFL because of player tracking data. And again, I would encourage you to go get your hands on this data and experiment with it. Second piece is approaching subject matter experts with humility. Many of you on this call may have advanced degrees, master's degrees in statistics, PhDs in engineering, operations research, whatever your field or discipline may be. If you're going to get into sports analytics, just one general piece of recommendation that I have is to approach subject matter experts with humility. Many coaches and executives may not have formal PhDs, but they've been around the game so long that they have what I like to call the equivalent of PhDs in their respective domains. And that before you put something in front of someone and essentially ask them to completely change their philosophy because of a research study that you did, I think it takes a certain level of humility to be able to approach those decisions or those conversations that way. Last two pieces here, certainly related to the items above, is if you can't clearly explain your work, don't expect somebody to buy in and use it. If it's not transparent what's going on with your analysis, it's very difficult for people who maybe are non-technical to be able to understand it and actually buy in and use it. So place a huge emphasis on being able to explain your work. And then the last piece is that continue attending events like today. Everybody started from scratch at some point, whether you're just getting started as an undergraduate, you're continuing, you're thinking about a career change. I would highly encourage you to continue attending events like today. And then last piece here as I wrap up, if you're interested in more contact information, you can contact me on Twitter. I will say that I've been under cloak and dagger for a few years working for teams. So my Twitter activity has been extremely limited. I think I have 2 tweets to my name at this point. So I anticipate that changing here in the future, but you can contact me on Twitter at Mitch Tanney. These slides will be posted on GitHub at Mitch Tanney. And then you can also contact me over email at these 2 different email addresses. And with that, Rachel, I will turn it back over to you.
Awesome. Thank you so much, Mitch. There are a few questions on the Slido, and I'm noticing a few questions coming into the chat too. So just so I don't miss any questions in the chat, if you don't mind putting them on Slido, that would be really helpful. But Mitch, a few questions for you from the Slido. One from Chris is, do you recommend any data sets that detail when a timeout challenge was used throughout a given game? For example, we can know the score at the time of challenge.
Yeah, any data, if you're looking for public data sets, the group at Carnegie Mellon, I want to give them credit, a few years ago, started NFL Scraper, and then that's now turned into NFL Faster. I believe I'm saying that right. So it's NFL FASTR. It's an R package. It's on CRAN. I believe it's on CRAN. You can go grab that, and it's play-by-play data. I see someone there confirming that. So yeah, it is on CRAN. So you can go grab you can go grab NFL play-by-play data, and that includes win probability, expected points, and a host of other things. So again, go check out that package if you're not familiar with it. You can't get your hands on data directly from the league. And then another data source to go look at if you really want to test your analytical skills and just general framework for approaching large data sets is go use the Big Data Bowl data. So it's player tracking data that's available for players. And I can't remember how many weeks are available on that data set, but that's movement data for all 22 players on the field, if I'm not mistaken. And it's a sizable data set.
Great, thank you. One of the actually most upvoted questions I want to make sure I get to is teamwork online really the primary avenue into professional sports jobs, particularly the NFL? Are there any better suggestions?
That's a loaded question. I'm not sure how to answer that one. I'd say a lot of it is right place, right time. I mean, I was really fortunate. I'll speak to my experiences. And again, I think anytime you talk about your career, when you have certain breaks that fall for you, I certainly had a break that went in my favor. I was working for Stats Inc. They've since been merged with Perform, and it's changed ownership a little bit since I worked there roughly, 10, 12 years ago now. But I was working in essentially a startup group at Stats, working with teams, and the Chicago Bears were a client of ours. And I developed a relationship through that. And next thing you know, I found myself sitting in House Hall working for the Bears. And again, a lot of that was luck, being in the right place at the right time. I'd like to think that, my work had, certainly influenced it as well. But it was also, there was a lot of luck involved. So in terms of recommendations for people to get started, you have these unbelievable platforms with social media to be able to show your work, direct message people that are involved in the field, LinkedIn, Twitter, and so forth. So be able to just reach out. Teamwork Online is certainly one source, but there are others as well.
Thank you, Mitch. And we have time for a few more questions here, and I'll make sure to send the full list of questions to you as well, and maybe we can go through and make sure that we answer everything after as well.
Sure.
But another question is, how were analytics used for rapid in-game decisions in your experience?
That was a big part of my work when I was working for teams, was being able to provide data-driven recommendations to the coaching staff on the field or that were also in the coaching booth with me. There are certain limitations with the league rules. The league rules currently prohibit any live data feeds. If that changes, I would anticipate the role of technology certainly changing for teams because you now have access to potential calculators for win probability and all sorts of things. There's certainly other ways to do that without live data feeds, but I think it requires a little more creativity from the team side of it. And there's also vendors that play in that space that provide data-driven recommendations with charts and tables and various data-driven decision-making tools.
Thank you. So let's see, we have time for one more question. Is injury data available via the Big Data Bowl set, looking into games lost to injury?
I don't know offhand. I'm not sure of. If there's somebody else on the chat that may want to chime in, please do. I'm not familiar though if there is injury data associated with that.
To Asma, I have a feeling you may know more information on that.
Yeah, I just saw Mike Lopez chime in. So thank you, Mike, for attending, and thanks for answering that question. So again, Mike Lopez is from the NFL. So thank you, Mike.
Mike, thanks for joining as well. Do you want to add anything to that on the Big Data Bowl event?
No, thanks, Mitch, for the great overview and for mentioning our event. We certainly encourage all folks, football fans, not football fans, to participate in the Big Data Bowl, due mostly to sort of sensitivity around the data. We haven't included injuries in the past. I don't anticipate that changing in the future, but we do welcome folks to get your hands wet. It's not just good preparation for work in football. It's a preparation for a career in really any sports analytics. We've had recent Big Data Bowl participants get hired in soccer, in the NBA, and it's just a good way to get your hands messy with tracking data, because really that's kind of where all sports are going. So yeah, thanks.
If I can chime in there too, I would argue that if you can handle the NFL's data, the tracking data, you're going to be well prepared to handle data in a lot of other industries, because it's an extremely challenging data set. It requires some technical chops to be able to interact with it. So again, if you're just a data enthusiast and you want to challenge yourself, I would really highly encourage you to go grab that tracking data, because it's a really interesting data set. There's a lot of different applications of that data.
Great. And we'll have some more time for questions at the end. I just want to make sure that we get through Meghan's talk as well. She has a great talk on extending R Markdown, but also just a quick announcement from Josh Orenstein, who's on from the National Basketball Association as well, about some of the NBA's NBA Future Stars program, if you want to let everyone know about that.
Yeah, Rachel, thanks for having me. My name's Josh Ornstein, and I'm a senior data scientist in the basketball strategy and analytics department at the NBA. And I'm really excited to be part of a program that we're launching called Future Analytics Stars. We're launching it in early August. It's a career development program targeted at potential interns and early career applicants for analytics roles throughout the sport, on the basketball and on the business and the marketing side. It's going to be bi-weekly, like 2-hour meetings. That's the general idea, where we'll feature real world applications of analytics and professional development opportunities and mentorship. The program will culminate in a capstone project that can be used as part of your portfolio if you are looking for a job. Yeah, and like I said, the goal here is to help people get placed into analytics roles. Applications are due June 25th. It's for US and Canada participants only. And I'll throw a link and my contact info into the chat if you have any further questions.
Great. Thanks so much, Josh. Just want to make sure everyone can hear me okay right now. I had a headphone issue.
You're good.
Okay, perfect. Thank you. So with that, I'd love to turn it over to our second speaker, Meghan Hall, who will be presenting on extending R Markdown from websites, slides, to PDFs, and more. So Meghan is a data scientist at Zealous Analytics and is currently teaching a course on data visualization at Carnegie Mellon. So I know Meghan from Twitter and from the Boston News Hour group, but she contributes to the public sports analytics community by helping beginners learn R, and also by writing and presenting on various aspects of hockey analysis as a member of Hockey Graphs. And so with that, I'll turn it over to you, Meghan.
All right, great. All right, I'm going to assume everyone can see my slides just fine. First of all, thanks, Rachel, for such a nice intro. And thanks just kind of overall for inviting me to speak. It is a true honor to speak about one of my great loves, R Markdown, especially at a meetup on R and sports analytics, because truthfully, most components of my career, and to be honest, like my hobbies and my social life, fit somewhere into the Venn diagram of those two things. In terms of the R side, I am a data manager in higher ed, so I use R, every single day in R Markdown. I'm also, as Rachel said, I'm currently teaching a data viz course at CMU that uses R, RStudio, ggplot, R Markdown, of course. And then more on the sports side, I am a data scientist at Zealous Analytics, where I focus specifically on data visualization and reporting in, you guessed it, R Markdown. And then also part of the decently active member of the public sports analytics community, mostly focusing on hockey and also creating tutorials and resources for beginners or people who are trying to get started with R through the lens of sports analytics, which I think is a pretty nice way to kind of usher yourself into the R ecosystem. But today, we're talking about R Markdown, which I think, again, we got Mitch's great talk kind of about the overview of decision-making in sports analytics. And I'm going to talk about a particular technical tool from RStudio called R Markdown that I think is really useful to tackle some of the specific things that Mitch talked about. So R Markdown is, at least in my mind, a really powerful and undervalued tool for a really powerful and undervalued component of data science, which is communication. We all know, or most of us probably know, that the tidyverse and all of its related packages make the analysis side of data science much easier. And I'm hoping today to convince you, if you're not already convinced, that R Markdown and all of its associated packages do kind of the same thing in making the communication piece of data science much easier, similar to the way that, again, tidyverse does to the technical side. Because I personally think that a lot of data science education falls a little bit short in terms of really emphasizing the communication piece, which again is a really essential piece of your kind of general analysis pipeline, workflow, whatever, because without this communication piece, your analysis can kind of exist in a silo. And of course, no one wants that. And this communication can mean communicating with yourself. Probably all of us have had the experience of opening a R script or whatever language you work in from like 6 months ago, and you're like, well, I wish I had commented that better. and you don't remember kind of the decisions that you made. So focusing on communicating with yourself clearly, first of all, is super important, can really save time. And also true to if you're talking about communicating with your teammates, as in like immediate people who you work closely with on the same projects. Being able to really clearly document, again, your decision-making process, why you chose these certain elements, maybe why you chose this model, why you chose to visualize this data in a certain way. Communicating all of that, and again, adding all the extra context that might be missing from just kind of a standard R script can, again, make it so much easier for your teammates if they ever need to reproduce or build off of your work. And again, kind of most importantly, communicating to people who are above you on the organizational ladder. Because sometimes, most of the time, the person that is doing the analysis is not the person who is actually responsible for making the decisions based on those results. Sometimes, it is depending on like your role and what organization you work for. Generally, there are at least a couple layers of people in between, like in sports, for example. The person who, if you're working in sports analytics for a company or a team, all the great analysis you're doing, you are probably not the one who is making decisions on player acquisitions or roster construction or game time decisions, et cetera, et cetera. And so being able to adequately explain your results to different layers of people, again, if you were explaining to a teammate, your analysis would not include the same kind of details and context as if you were explaining that to an assistant coach, for example. Which ties perfectly into something that Mitch said. We did not even coordinate this, but I was so happy when I saw this on one of his slides. I even wrote it down. If you can't clearly explain your work, don't expect a decision maker to buy in and use it, which is really so true. And it is a true essential skill to be able to, again, distill your analysis and either apply or remove context and technical details based on the audience that you're trying to present to. Because without, again, if you can't convince, say, your coach on the results of your analysis on timeouts, then your analysis is basically pointless. Most of us are doing this work in order to provide the data behind these data-driven decisions and hopefully make change. Now we can't, as I said, this is a really essential skill to have. Unfortunately, we can't go super in depth into how to develop that skill because I was only given 10 minutes for this talk and I'm not a magician, but I'm hoping to convince you again today that R Markdown is a really useful tool to use that skill. So many of us are probably, you've either been at this stage of a workflow or you know someone who's in this stage, or hopefully maybe you've helped someone who's in this stage who's using Excel for their data analysis. And I am never someone who, who poo-poos like Excel. Like Excel is a great tool, and being proficient in Excel and using it proficiently is a really essential skill, I would think, for a lot of data analysis roles, particularly if you work closely with people who might use Excel for, again, certain appropriate business cases and might have less technical roles than you do. But a lot of people do take kind of the capabilities of Excel a little too far when I think they could really be better served by using a tool like R, Tidyverse, all of its associated packages, et cetera, for making their data, the technical side of their data analysis work, more reproducible. So hopefully, again, people move to this next step, which is an amazing step. Again, just taking the data analysis and making that more reproducible using R is amazing. I personally stayed at this step for a very long time. And again, this is miles better than this first step I showed. But I think some people can stay in this step too long. As I said, I did, where I was really pleased with all the efficiency gains I got in moving my analysis work into R, but I was still handling kind of all the data communication pieces by kind of keeping all my documentation in Word documents and creating all my slide decks to, convey the results of my analyses to, various higher up audiences in PowerPoint. And so what I'm hoping to convince people is actually the ideal workflow is to substitute R Markdown for all of these kind of data science communication needs, because there are so many output formats that are possible with R Markdown, and keeping everything in the same universe, in the same ecosystem will kind of streamline the communication side of your data science work, just like using R, Tidyverse, et cetera, really streamlines the analysis part of your data analysis work. So we talked about how, you need to communicate at different levels. And many of you might be familiar with kind of what I call like a classic R Markdown document, which doesn't take any kind of special package. It outputs an HTML file. These can be really useful, again, to yourself and your teammates, as they really easily incorporate code and plots and text, generally text that's more fleshed out than just, short comments in an R script. This example is actually a lab assignment from my course, but it's a good example of how you can very easily combine text and code and plots into a simple HTML file that's, again, very easy to share, and it really makes you focus on reproducibility. I make my students use R Markdown because part of the class is learning about how to get used to a reproducible data science workflow. And if I cannot, reproduce your HTML file on my computer, you lose points, which, in the real world means your work is not as reproducible. So that is a great step. And then also in terms when you need to, start presenting to some layers of people above you, like if we stick to our example of you have all of your work that you did on analyzing like the values of timeouts, and your NFL coach wants this data, you're not going to send him, hopefully, maybe there are some coaches out there who would appreciate it, but you're probably not going to send him like your really long standard R Markdown file that has all of your different code decisions and your plots. Like, that's too much information. But thankfully, R Markdown has lots of other options. You can create dashboards with Flex dashboards. You can create slides with Sharingen. These slides I've created today are created, again, with R Markdown with Sharingen. These particular slides are pretty plain because this talk is pretty short and mostly talking about theoretical things and not necessarily showing codes and plots. But it's really easy to, again, incorporate code and or plots, and of course all the images and other formatting things that you would expect to have from presentations. But we can move away from the land of having to screenshot all of your plots and then pull those into your PowerPoint by instead in R Markdown, you can just refer to chunks, that code chunks, kind of the R Markdown verbiage. You can refer to chunks that already exist. And again, much easier, so you don't have to worry about when you make a change, either you get new data or you make maybe a change in your model, you don't have to worry about updating, again, all of these screenshot plots in your slides. And then lastly, might be more on kind of a personal note, if you ever want to communicate to the public, again, there are lots of R Markdown driven packages that do that. Bookdown makes it very easy to create like online books. Most of the kind of online books you've seen online, the popular ones about R-related topics, most of those were built with Bookdown. There are also several different R Markdown driven packages for website development. Distill is a very popular package. I personally have my course website that I created with Distill. And actually, as I mentioned, everything about my course is completely created in R Markdown, from my lecture slides to, again, assignments, etc. And then there's another popular R Markdown driven package called Blogdown that I personally use for my personal website. And again, these types of packages, again, for website development, being R Markdown driven means you build them with R Markdown documents, build them in RStudio, and even we're getting a little meta here, but the blog posts themselves, like this one I just chose as an example, is also driven by R Markdown. So again, it's super easy to combine text and code, which is easy for someone to copy, which is helpful for education purposes, as well as, of course, plots. And there are, again, several other even categories that we didn't get into today. There are special packages for creating journal articles. There are packages for creating interactive tutorials, like hosted, again, through HTML Online, which is super useful if like anything about your job involves any kind of education component. So I just kind of, spit off the name of like half a dozen packages, and you're probably like, oh my God, there's so many different packages to learn. But kind of one of the bright sides is just like how if you kind of learn the basic syntax of the tidyverse, is that kind of allows you to easily extend that into other related packages like tidy models and ggplot. The exact same is true for R Markdown. And I would argue it's even actually much easier. Once you have the basic syntax of R Markdown, again, as I mentioned, you can create things in chunks, and there's various options as to what you can do if you want to show or hide code or plots, etc. And once you're familiar with kind of the basic syntax of R Markdown, that means it's very easy to, all you have to do is, again, learn kind of the specific details about the various output formats in the packages, but it's really much very easy to just take whatever your analysis work is and easily make that into different output formats, whether that's an HTML file you want to share with a teammate, or a set of slides to make a presentation to show to someone higher up, which of course wouldn't have code, but would probably have some plots that resulted from that code. And so you don't have to duplicate that work. So I hope, again, it was difficult to distill all of my love for R Markdown into 10-ish minutes, but I hope that you are either inspired to include R Markdown, to start including R Markdown as a part of your workflow, or if you already use R Markdown a little bit, like maybe you kind of do your personal analysis in R Markdown documents, which is a great start, is that you realize kind of how much knowledge you already have, and you can really easily extend those capabilities into other formats and create slides and websites, etc. And so I've included a few links here. These slides will be posted, by the way, on my website and my Twitter. This first link here is just a basic R Markdown tutorial on the RStudio website, which is really great for just, again, learning the basic output formats and capabilities of R Markdown. And I've also linked here to the definitive guide of R Markdown, which is an online book, of course, created with Bookdown, that again goes into lots of details on all the various output formats. And then lastly, Allison works for RStudio and is, in my mind at least, the queen of R Markdown, and has produced so much great content on so many different aspects of R Markdown. So I have a link to the project page on her website. So if you have a question about R Markdown, or again, how to learn blog down or distill, etc., she probably has some content on it. So again, I hope this has inspired you to incorporate some more R Markdown into your life, and I wish you luck on that journey. And before I leave, I just wanted to mention, since we have such a great collection of people here who are interested in R, interested in sports analytics, I definitely want to mention that Zealous, which is a company that I work for that is an industry leader in the sports analytics space, is about to be hiring in several different roles. We're going to be hiring for data scientists and data engineers and analytics engineers, both at junior and senior levels. It's a really fun, really smart team that's doing a lot of cool work across multiple sports. So I'd really recommend that you either apply if you are interested, or just kind of spread the word. We're hoping to get a nice big candidate pool. Those job descriptions will hopefully be posted by the end of the week, and they will be on, again, the Zealous website and Zealous Twitter, and hopefully they'll just be floating around sports analytics Twitter, if that is a place where you hang out. Thanks again, Rachel and RStudio and everyone, for having me.
Thank you so much, Megan. If you have questions for Megan, if you wouldn't mind when you put them into Slido to put Megan's name as well, just so it's a little bit easier to sort through them. I think there maybe have been a few questions in the chat on Zoom. If you could copy those over as well, it'll make it easier to sort through. Thank you. And one question that was just shared, Megan, is can you collect user data via BlogDown?
Oh, that's a good question. I actually don't know. I would have to look into it. My personal website, I don't have any tracking. Like, I don't have any tracking data or data on who visits my website, but I assume there are probably options. It might depend on who you host your website through.
Thank you, Megan. And next time I will definitely have someone help me with moderating the Zoom. Moderating the Slido. So if there's any questions for Megan that I've missed, feel free to just say them out loud as well. But something I wanted to ask you about, Megan, is I know you commented when people were asking about how to potentially be hired by a sports team, and you said like putting your work out there and having public work. Would you be able to speak a little bit more?
Yeah, it's certainly not the only avenue to work in sports, and whether that's working for a team or working for some kind of associated company, like the company I work for is a consulting company basically that's hired by teams in various sports. So as kind of Mitch was mentioning, it does certainly depend on luck. For most sports related jobs, there tend to be a lot more qualified applicants than positions available, just because it tends to be a popular industry. So there are certainly people who just get hired either straight out of school or because you apply. But a lot of people also at least get on people's radar because of public work that they have. So becoming involved in really any way in the public sports analytics community, again, whether that's, you know, in one sport or in multiple sports, there is some kind of data out there for at least most of the major sports. You know, the quality and kind of quantity of that data can vary by sport, but people know obviously if someone is hiring from within a sport that doesn't have a lot of public data, they're aware that's a restriction. So just kind of, again, using it, just exploring, same as what Mitch said, just kind of doing it. And it's a great way to learn R also. If you are a beginner, is just figuring some kind of question you have and finding the data and like learning as much as you need to know about R to answer that question. And so having some kind of portfolio of public data in some kind of easily available place, again, whether that's GitHub or a super basic website, is, again, really helpful. Because I can tell you, even from, again, we're about to start hiring at Zealous, and I know a lot of people have, you know, internal at the company just have lists of people that they're aware of in the analytics community just by, you know, work that they present. So getting involved in that and really presenting any of your work, having some kind of public record of the work you can do is always useful.
That's a great point. And I see two other questions for you. One is, how do you think hockey stats compare to other sports for analytics? Is it easier to use or more definitive results, larger or smaller sample sizes?
I think it depends on the type of data that you have access to. The public data for hockey is nice in that it is consistently available, but it is not super particularly detailed. I mean, in saying that, I think there are plenty of insights that have been gained from the data that is publicly available. And I would argue there probably still are insights that can be gained from that data, but probably a lot of the kind of cutting edge, again, more of the tracking data, we know that exists for hockey, but it's not publicly available at the moment. So probably most of the, again, more cutting edge advanced techniques are coming from, again, data that's still internal. But I do think there is a decent amount of data available for hockey, at least in terms of the NHL. It does vary wildly as you move into either women's hockey or other leagues, junior leagues, et cetera. But I do think there is a decent amount of public data for hockey.
Thank you. And last question is, do you have any recommendations as to where to host some R Markdown site?
Yeah, so everything that I have hosted, again, I have two websites, one that's built through Distill and one that's built through Blogdown. Both of those are hosted through Netlify, which is a pretty common workflow for hosting these Markdown sites because it connects super easily with GitHub. So if you just have the GitHub repo for your site, it connects and it's free. I do have, again, my course website has this netlify.app at the end. You can, of course, pay for a custom domain name. I don't really care for a course website, so I have this. But if you're just a personal R user and you like use your website for R related purposes, you can get for free, again, you could just Google it, you can get an rbind.io address, which you'll see pretty common. So this is, you know, a little more custom just with my name, but this is also free. But this is meant to be for people who are, you know, have some kind of blog, you're doing tutorials and, you know, again, trying to share our knowledge.
Great. Thank you so much, Megan. And thank you, Mitch, for your presentation as well. I know there are quite a few questions that are on Slido that may have gone unanswered in the time we had today. So I'll be sure to share all the questions and take them from the Zoom chat to share with the speakers to get answers for you. So much, Mitch, and thank you, Megan, for your presentations. Have a good day, everyone.
Everyone, thank you.